Well, hello and welcome to Math 2355. This is our first lesson in this class, and it should be a review. But of course, I want to go over it just in case you don't remember some of the ideas and concepts for this one. So we are looking at linear equations and linear inequalities. So remember, inequalities are greater than, less than, right? Signs. So it's like this over here is greater than this over here, or less than, right? So whatever's on this side is less than what's on this side. So greater than, less than, or you could put the line on it, right, and be equal to as well. So this first part of the note packet kind of just goes over some reminders here. And I'm just going to bounce into the problems. And when you do have the inequalities, you have to put the answers in interval notation, which is one of the reasons I leave this on here. For one, it's a good start to a class, something you've remembered or you've seen before. Also, we do everything in interval notation. So for business calc and business apps. So I want to make sure you know that. So here's our first problem. So we see that there is a 7x and a 2x. So there's an x on both sides, or a variable on both sides. So we want to put those together first on one side of the equal sign. So when they're on the opposite side, we got to do the opposite of what we see. So what I'm going to do is I am going to minus this 2x over to this side so that they go to 0 here. So 2x minus 2x goes to 0. On this side, I'm going to end up with 5x. Then you still have the plus 8, you still have the equal, and you still have the 28. You bring everything down, right? So you put those variables together on one side of the equation, okay? Then from here, I only have one variable, the 1x there. So I got to get rid of the 8 and the 5. So the 8 first, because it's added and subtracted outside. So I do the opposite again because I need to move it to the other side of the equal sign so that they go away here. Oh, I wrote 7. I caught it when I went to make them go to 0, and I don't think that makes 0. So 8 minus 8 is 0. So now I only have 5x on this side equals 28 minus 8 is going to leave us with 20. So last step is to the opposite of times, which is to divide. So I'm going to divide by the 5. That's going to leave 20 divided by 5, which is 4. Okay, so 20 divided by 5 is going to leave 4. So that's our solution. How can I check the answer? Well, I go back in and I go, well, 7 times 4 plus 28 better equal 2 times the 4 plus 28. All right, well, 7 times 4 is 28. So 28 plus 8 for some reason is 26. And then on the other side, 8 plus 28 is 26. So it does work on both sides. Okay, hopefully that didn't pop up for you. If it did, I don't know. It popped up like a control because I set the iPad down on my mouse. Okay, so that should definitely be a review. Problem 2 is somewhat similar, right? So you're going to have to distribute here and simplify that whole left side before you can start to solve going both directions like we did on the last one. So we'll start with distributing the 3. So I have 7y over here, and then 3 times 6 is 18y, 3 times 11, and it is a minus there, is 33, equals to 167. So I still need to simplify on that left side. There's no opposite sign, so I do exactly what I see. 7 plus 18 is going to give me, what, 25? Y's, and then you have the minus 33 equals the 167. Okay, then from here, what we want to do is we want to add the 33 over. So I'm going to take 167 and add the 33. Because now I can go to the other side once I've simplified anything that needs to be simplified on both sides of that equal sign. This one goes to 0. I'm going to have 25y. I hope this makes a pretty number, and that does. It adds to 200 evenly. And then how many times does 25 go into 200, right? We divide this way. And if it was a fraction answer, then you'd just be done with the fraction right there, but it does go in evenly, leaving 8. So y is 8. You can go ahead and check by plugging that back in. Okay, so how do we solve a problem with a fraction? Well, we can multiply by the common denominator, okay? So what is a common denominator for 6 and 3? You times them. So 18 is that common denominator that we could use, or we could use 12 because 6 and 3 both go into 12. Sometimes you don't think of the 12 and then you'll just have more reducing later. It's not that big of a deal, but you can always times them. So this is the common denominator. And we'll use 12 just because we know we can use 12 or 18, whatever. And then what you do is you multiply by this. And you're going to multiply everything by 12. And you can think of it as 12 over 1. And you're going to multiply every single term on both sides of the equal sign, because that makes it legal. I'm going to multiply a scalar of everything. So when I multiply this first term, the 6 goes into the 12, leaving a 2m, okay? And then what is 12? I'm using my calculator. I don't remember what 12 times 8 is. It's 96. So 12 times 8 is 96. Okay, and then 3 goes into the 12 4 times. So I'd have 4m left there. And then 10 times 12 is 120. So this solution, or excuse me, this equation is just a scalar of the other one. So they have the same solution, but man, this one looks way easier to solve than the one with the fractions. Now, if you're good with fractions, then you can solve it with fractions. But a lot of people just aren't. So this is a great trick. All right, then I want to minus the 4m over this way. You could have gone the 2 the other way. That's fine. I have a negative 2m here plus 96 equals the 120. Okay, minus the 96 over to the 120. And I'm going to have negative 2m equals, what is 120 minus 96? 24. That's positive. Okay, so positive 24. Now we have to divide by the negative 2. Divide by the negative 2. This one goes to 1 because 1m equals what? Negative 12. Okay, and we could go put that back where the m is and double check that solution. Okay, so the next group is inequalities, right? So greater than, less than type problems. So one big rule is if you multiply or divide by a negative, you have to switch the inequality. Okay, so wherever you want to write that, maybe I'm going to switch and kind of write it up here. If you multiply or divide by a negative, then you need to, I did not leave myself enough room, switch inequality. Sign. Okay, that's our one rule. So if you multiply or divide, you have to switch inequality. Now look at the problem we just solved. Is it this one that shows? No, it's this one, right? Okay, so look at the problem we just solved. We are adding, subtracting, multiplying up here. This is really the first time we're dividing by something or multiplying. So it's truly the last step where you decide if the rule is going to apply. This last step when you have the inequality. So let's solve this first one here. Solve it just like it has an equal sign. So I'm going to minus the 4 to both sides. Oops, I wrote a plus. Minus the 4. So I have 9x is greater than, minus the 4 is going to be an 18. Didn't divide by negative. And now I'm going to divide by 9. Is that 9 negative? Nope. Then I keep it greater than. So these would go to 1, and I'm going to have what? X is greater than 2. So there, we draw a graph and we do interval notation because there's lots of answers. We are only restricting that the value is greater than the number 2. So if we had to put it on a number line, then we would have what? 0, 1, 2. Here's the number 2. We would have an open dot and we would point towards those greater numbers. Okay. So another symbol, I'll write this over here. If you have greater than or less than, like this, right? It's an open dot or curved in a parenthesis. So I could have done this same graph at this 2 with a curved parenthesis. Why do you think we would use a curved parenthesis instead of an open dot? It's a weird reason. Can you type an open dot? No, because 0 is not an or an O, right? Like you can't type it, but you could type an open parenthesis. So this really does lend this inequality notation to computer science and being able to type them. Okay, so if you have the equal sign on it where you could be at that spot, so I could be at the 2 if that was there, it would be a closed dot on the graph and a square bracket for the interval notation. So just note that. Okay, so if I go to do interval notation for problem 4, I'm saying you're starting at 2, so the lowest you could possibly be is 2. So round bracket at the 2, comma, and the highest you could be is infinity, because we don't really know, we don't have a high spot, we're just greater than 2. So interval notation, lowest to highest with a comma in between and either round or square bracket. Okay, and the infinities, either one, are always round brackets next to them. Okay, that's my little cheat sheet for you. Okay, this next problem is written to solve compound inequality. So I couldn't think of the name of that for a second. So you could actually solve both at the same time, or you can separate them and solve them separately. If I was going to write them out separately, it'd be a -5 is less than -2x plus 1. There's the first half. The second half is -2x plus 1 is less than 13. And then you solve those separately. You can also solve them together. So I'm going to erase these. You're welcome to keep them. I don't have enough room, but you see the idea. You can separate, but I'm going to do it together. Oops, I erased part of the other problem. Okay, so what I'm going to do is I'm going to do it from the middle here, this middle section right here. And I am going to look at that and think, if I was going to start anywhere, it would be with that +1 by minusing the 1 over. And when I do, because you could kind of look at it as just like part of it, right? Cover up the -5 less than, it's like, I know I could minus the 1. Whatever gets you to think of minus the 1, but I do it on this side and this side. So you just do it on both sides at the same time. Okay, so then -5 minus 1 more is -6. And now is less than, the middle has -2x, is less than 13 minus 1 is 12. So now I have a -2 in the middle, and I need to divide by that -2 both directions. This one hit our rule of switching your inequality signs, because right now when I'm writing a negative underneath, I am dividing by a negative. So this is dividing by a negative. So I got to switch both of those inequality signs because I'm dividing on both sides. So over here, -6 divided by -2 is a +3. It's now greater than, and then only, I don't know how I did that. So greater than, that was weird. It must like connect to a symbol of some sort. Okay, and then the middle is just going to be x, and now we switch this one to be greater. 12 minus, or 12 minus, divided by -2 is a -6. And this is our solution. Now, this is written backward now. We don't like to say x is greater than -6, and so we're reading it this way. X is greater than -6 and x is less than. We don't like to do it this way. We like to see this as the lowest number. So the point has to stay pointing at the -6, right? X, and then this, we like it this way because it's saying you're between these two numbers here, which is the whole idea of a compounded one, right? Low to high. So I will rewrite this. So you should be able to recognize this is correct. There's nothing wrong with it. It's just kind of weird notation. Okay, so the next one here is that interval notation. We still only have less than, they don't have any with an equal. Oh well. So our lowest number round bracket is -6. Our highest number is 3, round brackets for both because it's just less than or greater than. Okay, and again, you read this from the middle. X is greater than this and X is less than this. It reads the same here. X is less than this and X is greater than this. They reads the same way. Okay, so read from the variable. All right. Let's check it. So the next one we can solve by multiplying by a common denominator again. I think I might just skip that one. I think you're good. I think the biggest thing is remembering this here and seeing an inequality with this here and the graph. I could graph this one as well, right? It'd be at -6 and 3. I didn't fill in all the middle numbers, but there'd be a 0 here somewhere. It's a round bracket, and your every number in between. You could also have done an open on both of those. Just depends on what they want to type up. Okay, let's skip to this break even. A publisher for a promising new novel figures fixed cost, overhead, advancing promotion, copy editing, typesetting, and so on at $87,000. Variable cost at printing, paper, binding, shipping at $4.50 for each book produced. If the book is sold to distributors for $28 each, how many must be produced and sold for them to break even? Okay, so the book is sold to distributors. So we're looking at costs. And our variable cost has to be multiplied by how many books we have. So I'm thinking just for cost, it's $4.50 per book. So we'll let X be the number of books. So this is per book. So $4.50 per book produced. And if the sold distributors, how many? They're sold at $28 each. Because this would be plus, the cost would be plus 87,000. Oosh, kaboosh, that's gonna be a lot. Break even would be where they equal 0. So what I think I'll do is just set this equal to cost. So I was trying to think of, like, I was pausing because I was trying to think of how I wanted to explain it without systems of equations, which is our next section or chapter. So then we think about how much money, that's our revenue. How much money are we going to make off this thing? That's going to be the $28 times the same X, right? Because that's our number of books that we sell. So $4.50 is the cost. $28 is what we make. So this is revenue. And break even is where revenue and costs are the same. So we can set these equal to each other. And I'm not good at, I wouldn't have been able to think through this equation right off the bat. Maybe you can. The way my brain works is I got to think of how cost is and my money I'm making, and then I set them equal to each other. Either way works. Now this looks somewhat similar to something we've been doing, and I'm going to minus over the $4.50 X, minus that over this way, because we know, and you could have probably thought of it this way too, we know that we're making $23.50 per book. You could have thought of that already. excuse me, so that's gone. 87,000 equals we're making $23.50 per book, and then divide that over. So 87,000 divided by 23.5, I get 3,702 0.1, but we can't really sell a 0.1 of a book, so our answer would be 37 and 3. We always round up because I'm not going to make enough money off of 3,702 books, right? Because I'm short 90 cents. So then I have to, or 0.1 doesn't necessarily mean 90 cents, but so I have to round it up. So you probably could have jumped right to this as well, if you're just depending on how you thought through that problem. All right.